Okay, the last example I'm going to show you is a rectangle. So if nothing is labeled on your rectangle, you want to start by labeling everything that the problem actually gives you. So it says that AC is the diagonal, of your rectangle. So that's 15y plus 10. And further, we have that BD, which is the other diagonal, is 18y minus 2. So I've got two sets of diagonals. So think about what properties do you need to know? So the properties for this one is that the diagonals of a rectangle are congruent. So if the diagonals are congruent, that means that 18y minus 2 is equal to 15y plus 10. So AC is congruent to BD, which means that if I substitute the values in there and I want to solve for the length of the diagonal, I can set 15y plus 10 equal to 18y minus 2. From there, I'm solving just algebraically. So whatever you want to do to start, if you want to move the y's first or a number first, I'm going to choose to move 15y first. So I'm going to subtract 15y on both sides. So I'll get 10 equals 3y minus 2. The next thing I'm going to do is I'm going to add the 2 over. So I'll have 12 equals 3y. Divide by 3 on both sides, y equals 4. But that's not ultimately what it wanted us to solve for. It wanted us to solve for the length of the diagonals. Well, the diagonals are the exact same lengths. So all you have to do is substitute your value for y into one of those diagonals and you'll solve for both the lengths. So if AC equals 15y plus 10, I'm going to substitute 4 in for y. So 15 times 4 is 60. 60 plus 10 is 70. So AC equals 70, but so does BD because our diagonals are congruent. So anytime you start these kind of problems, ask yourself, what properties do I need to know? Is something congruent? Is something supplementary? And from there, it's just algebraic.